to close out chapter 19, we're going to talk about choosing the sample size for a study or an experiment. So back when we did that in chapter 11, 12, 13, we didn't know what sample size to use. We just said we'd use a sample size, no big deal. But now we know we have this success failure condition that has to be met. You have to have NP greater than or equal to 10 and NQ greater than or equal to 10. So you have to have a specific sample size for that condition to be met. And it would be nice if you could plan your survey around that so that you could do your survey and at the end be able to use some of these procedures, like create a confidence interval. So from yesterday, we know that the margin of error is equal to the critical value times the standard error. Okay? Well, if I know what margin of error I would like to have at the end, and I know what confidence level I'd like to have at the end, and I have a p hat and a q hat I could use, then I could just do some algebra and solve for n. And so that's what we're going to do. All right? Now, you have two options for p hat and q hat. You can either base your standard error off a old sample of some type, or if you have no old sample, you can always use p equals 50%. That's very cautious, and that way it'll determine the largest sample necessary regardless of the true proportion. You just have the largest sample you need. Okay? So here's an example. It's believed that as many as 25% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among the 25 to 30 age group. So in part A, it says how many of this younger age group must we survey in order to estimate the proportion of non-grads to within 6% with 90% confidence. All right. Well, again, we know the margin of error is equal to our critical value times the standard error. Well, I know my margin of error. That's what they told me, within 6%, so 0.06. They told me 90% confidence. Now, if you don't remember what 90% confidence is, because you don't have to remember, you just draw yourself a normal model real fast. You would want the middle 90%. That would leave you 10% left over. That's 5% on each side. And so if I want to find this particular z-score, I would use inverse norm for 0.05. And that gives me a z-critical value of 1.645. All right. For my standard error, they give us a p hat in the question. It says it's believed that as many as 25% of adults over 50 never graduated from high school. If we're going to see if it's the same in the other age group, then we can use that for our study just as an estimate. So 0.25 times 0.75, and again, we're solving for n. So now we just need to do some algebra. If I were you, I would divide by 1.645. That's just fine. So you get 0.0347. That equals the square root of 0.1875 divided by n. So now I need to square everything. I get 0.00133. That equals 0.1875 over n. So at this point, technically you're cross multiplying. You don't have to show every single little teeny step if you don't want to. And so n equals 140.93. Now, you can't survey 140.93 people. It just doesn't work. So you always round up. I'm going to survey 141 people. If you're trying to find the sample size, you use the information that you have. So in part B, it asks the same question. Suppose we want to cut the margin of error to 4%. What's the necessary sample size? Do the entire algebra problem again. You just replace 0.06 with 0.04 in the beginning. And see, what sample size would produce a margin of error of 3%? Again, you're just changing the 0.06 to 0.03. If you can remember the margin of error is that stuff after the plus minus of your confidence interval, then you always have that equation that you can use to find the sample size. There's also things that can go wrong, and I suggest you go back and read these in your book. A lot of them have problems with what the interval means. We've been through that a lot. Make sure you know what to say about the interval. Do not make up your own statement because you generally are going to go wrong. Make sure your margin of error isn't too large to be useful. If you have a huge margin of error, then you can't really tell anything, okay? Um, one way to make the margin of error smaller is to reduce your level of confidence. That's one way. And then if your margin of error is small enough to be useful, then you want to make sure that you go ahead and compute confidence intervals, make sure that it makes sense. There's lots of things you can do, all right? To get a narrower interval without giving up confidence, you need to have less variability, and that means you have to choose a larger sample. All of these things are going to go back to those questions in the book about if I change the confidence level, what happens to my margin of error? If I change the sample size, what happens to the margin of error? And then make sure you're careful with the assumptions. There are several times questions that I give you for homework that the conditions aren't met, so you can't move on and you're wasting your time. Always check the conditions first.